Do any of you have Halloween festivities this week? Are you dressing up at all? Anybody else dressing up? What are you dressing up like? Oh, Thomas, that's awesome. Because your last football game, did you win? Yes, and you had, oh, I love that you had your girlfriend or a girl you like for a family dinner. That is so sweet. Dude of the year. Oh, yes. That sounds very sweet. We're throwing out all the single cards. Riley, you're going to be the front man from Squid Game. I don't know who that is, but it sounds fun. Y'all are still young. You still have plenty of time. Kinsley's sending a wake-up call to Caden. You're going to be his alarm clock today, Kinsley, when he starts drifting off. Anybody else dressing up this week for Halloween? My girls are they dressed up for pictures on Friday, but they are Belle and Snow White. Awesome. All right, well, this week we are going to talk about energy. The Nearpod code. You can use the Nearpod code. There was a lot of trouble with posting in Nearpod for some reason. I'm not quite sure. I'm going to work on it today. But I sent out a PowerPoint. I'll put it in your plan today as well. To just copy and paste your stuff in. So that there's no chance of losing it. Because I would hate anyone to work that hard and then lose it. I tried turning my camera on for a minute. My internet is lagging really bad today. I'm here. I'm awake. My internet is just struggling today. It knows it's Monday. So this week in class, we're going to look at glycolysis today. Tomorrow, the Krebs cycle and electron transport chain. And on Wednesday, we'll look at photosynthesis. Okay? So this week is all about energy. I think that's appropriate for Halloween week, right? It's literally about sugar. How appropriately did that line up? So we're going to learn about sugar on the week of Halloween. How our cells need it. My voice is tired this morning. Who will be a hero and read our goals today?
What is the chemical equation for cellular respiration? What are the reactants and products of cellular I can't say it. Respiration? And where does the anaerobic respiration take place? Also, explain how reactant and products of cellular respiration are important to anything alive.
I love it. I love the accent.
Spy gaming.
He's got to put his promo in there. Is Caden okay? Caden, they're worried about you. Should we be worried, Caden? I think Caden is just tired today. So
I had 1 to 3 hours of sleep.
yes, he's not sleeping well. I'm not sleeping well either right now,
No,
Caden.
no. 1 to 3 hours. Not 5 hours like most people. 1 to 3 hours. So I can bet y'all not having that much sleep.
Oh, well, we don't know. Everybody's dealing with a little something different. Hopefully, we can just bring the energies we have today. All right. And try to put them to good use because I've decided that Mondays come around, every day's come around every day. So we might as well make the best of whatever today looks like, whatever your situation today looks like. We can take it and hate on it, or we can take it and do our best with what we've got. I think on the end of Monday, we're going to feel better if we take what we have and try to make the best of what we've got. So if we're tired, let's bring everything we've got today. If you're sad or down, or maybe you've had a great weekend, let's bring everything we've got today to the table. All right. So over here today, you're going to notice that our goals are in different colors. So from now on, I'm going to try to highlight our goals to where we're targeting our levels of understanding. Right? As you start learning information, we learn on this knowledge level. But by the end of the unit, we should be closer to some of these goals up here of being able to analyze things and synthesize, which is put things together and break them apart and make evaluations based on what we know on the topics. All right, so this would be where we are at with our cellular organelle projects. So let's just do some self-evaluation today. If I had to ask you what cellular respiration is, how would you feel? Actually, can I change that poll? I put green check, red X. Let's not do that because I feel like the smiley face chat is more accurate. How do you feel? Would you be able to tell me what it is? Write down an explanation. Good. Pretty even poll. I'm going to show you. We're right here in the middle, almost a split. What does cellular respiration have to do with, friends, since we feel decent about it? One word that you might use to describe it. I love that you say that, Alana, because I always think respiration is breathing. I feel like maybe because that's like how we respiration is in our bodies, got to do with breathing. It isn't have to do necessarily with breathing. Kind of, Brianna. You need to, your cells are have to have it to be in a homeostasis. Oxygen is needed for the process, Elijah. These are really good guesses. Think about sugar. Cellular respiration is going to be the process our cells go through to make energy, to make a usable form of energy. Yes, glucose. I know. It's trickier than you think. Cellular respiration, I don't feel like is a name that leads on to its accurate description. All right, so what are the products? If I had to say, what do you need for cellular respiration, would you know? What do you need and what do you get out of the process? What do you start with and what do you get? A lot less of you are sure of that. Okay, so we're going to talk about that today. And where does anaerobic respiration take place? If you've ever heard of the word anaerobic, how do we feel about that? Yeah. The more detailed we get, the less confident we get. Last but not least, explain how reactant and products of cellular respiration are important to living organisms. How do you feel about that? How the reactants and products are important for life? Good. All right. So we've got a lot of meh faces, so we've got a lot of learning to do today. All right. Here we go. Let's dive in. I love food. How about you? Favorite food right now in chat. If you could be eating anything right now, or today, chicken, tacos, sushi, steak, Alfredo, Vanessa, yes. You're right, Alex. Cheese balls, cheesecake, bacon. Ooh, that's a good one. Spicy chicken carbonara. Oh my goodness, that sounds delicious. My friend Tori makes the best cinnamon rolls. They are like this big, guys, and like that thick too. I mean, they are these ginormous monster cinnamon rolls. So good. Spaghetti, potatoes, bread, chicken feet. Do you really like chicken feet or are you just being funny? Deer cheesecakes, burritos, watermelon, raspberries, more, burgers. All these things are good. All right. Believe it or not, all of this food, right? All of the food you get gives you energy, right? Where does your food source get its energy? So some of you said chicken. Some of you said deer or steak, which is cow. Some of you said pig.
Can I explain deer?
Yes.
I have the mental capacity to do that. So deers tend they don't eat meat. Okay, yep. So they go from the sun, if I remember the food chain, the sun to the plants or grass. I'm gonna assume it's grass, and they're cows now. To grass, to the deer, to me.
Yes. Perfect.
I love deer meat.
That I have to try it. I haven't tried it in a long time. My grandpa was an avid hunter and would do that almost every season. Kaden is sleep talking. That's okay, Paige. I'm the same way. I'm right there with you.
So basically how this works is the grass eats the sun, the burger eats the grass, the human eats the burger.
There you go, Jaina. I love it. Anybody else? Anybody else want to walk us through? Yeah, so essentially, whatever. Go ahead. Is somebody speaking?
The sun goes to the grass, goes to the cow, goes to the milk, which turns into cheese, and then I get cheese balls.
Yes.
Cheese.
I love it, JB. Perfect. Yeah, so all of our energy sources all have a common denominator in being plants and the sun, right? So when I say that our cells make energy, they don't necessarily make them like make energy from scratch, because if we've taken any kind of physical science lesson, energy cannot be created or destroyed, but energy can be transferred and energy can be converted. Okay. Just like we talked about last unit, that we can convert our money, like our American dollars, we can convert to many forms of international money. All right. If we went to Mexico, I would convert them to pesos. If I went to Honduras, I would convert them to lempiras. All right. So we are going to convert energy in our bodies from glucose from the food we eat to who can remember the 3 letters? It may or may not be on the slide. What type of energy do our cells need? Yes. ATP. Will everyone type ATP? Because all week we're going to be talking about ATP. Kaden, do you have 2 or 3 dogs? 3. Everybody's admiring your cute little pups. All right. The cellular respiration, what is it? This is our first goal, guys. How we create energy that our body needs to do. So if you need to move, if you need to breathe, if you need to think, if you need to go. The dogs were on his lap a minute ago. I think, are they still with you, Kaden? Oh, there they are. They're snuggling up. Oh, and Caden's dogs need energy just like we do. And believe it or not, his dogs are going to convert energy the same way we do. So for anybody to move or breathe, we need ATP. ATP. So we are going to look at the process this week of how our bodies, how our cells get glucose, break it down, and make ATP. I like to think about this like cooking. How many chefs do we have in the house? Any cooks? Leah's a cook. I cook because I have to. All right, so let's break this down. If we were cooking something, these would be, oh man, I didn't mean to do that. Undo. Is it going to fill it? No, it's not going to fill it. Fill my shape. There we go. Okay. If we were going to be cooking, ooh, grilled cheese. Still learning. Awesome. Vanessa is too. Awesome. So if we were going to make something, there's always going to be an ingredients list. So if we could like go to our kitchens and get the ingredients for cellular respiration, there are 2 things we need. What are those 2 things we need? Somebody? Want to get on the mic? What do we need?
Screen, yeah, it says glucose and oxygen.
Yeah, perfect. So if what it would list under your ingredient list for the recipe for cellular respiration would be glucose and oxygen. So glucose what? It is what? A fancy name for, yes, Thomas, sugar. All right, we need sugar. Where do we get our sugar from? How do our cells get sugar? All those favorite foods that, yes, perfect, food. Any of those foods that we talked about today, any of the foods you eat, some of the things you drink give you sugar. All right, the other thing you need to make cellular respiration is what? Oxygen. How do we get oxygen? Don't overthink it. You're right, plants, you are all right. Plants put out oxygen, and we get the oxygen by just simply breathing it in, right? Everybody take a deep breath. Do some yoga this morning. We get oxygen by breathing in. So we get our ingredients to make cellular respiration from our food and from our lungs, from our bodies. Breathing in and breathing out. Hi, Jasmine. So glad you're here. All right, so let's cover up what we get. So usually you pick the recipe you're making based on what you're going to get at the end. So some things you get at the end because you want them, right? So like when I'm trying to think of something that gives me a product that's in the middle. When I make homemade noodles, anybody like noodles? Yes. So I like to make like homemade egg noodles. You could use them for mac and cheese. All right. So what I do is I get my ingredients. I get flour, I get water, oil, eggs. Okay? I mix them up, and what I'll get eventually at the end is I will get noodles. But along the way, I'm going to roll that dough out. I'm going to cut it up. I'm going to also get some like scrap flour. Okay? Ooh, beef and noodles is your favorite? That sounds good. So there are going to be products sometimes that are like byproducts of what you're making. So when we make or convert cellular energy to ATP, we get two other things as products as well, as waste products. Things that our cells aren't using, but they make in the process of making energy. What else do they make other than energy? They make carbon dioxide and they make water. And how cool is that? Because you were talking about, right, how plants produce oxygen and they give us oxygen to breathe. And look how nice we are. When we exhale, we get rid of carbon dioxide, which is what plants actually need. When we get to photosynthesis this week, you're going to see that carbon dioxide is a necessary component. It's an ingredient for photosynthesis. So we are opposites in that we need oxygen and we give them our carbon dioxide, and plants give us their oxygen and they need our carbon dioxide. All right, so this equation below is exactly what we just talked about. This right here, C6H12O6, that is the chemical equation for glucose. So glucose plus oxygen, this arrow means equals or yields 6 carbon dioxide molecules, 6 water molecules, and energy. All right, which is what we are trying to work at getting today. So that's goal 1. Glycolysis. Can anyone read this slide for me?
Cellular respiration is a long process that occurs in 3 stages: glycolysis, Krebs cycle, and electron transport chain. Glucose is broken down in the cytoplasm. Does not require oxygen. Anaerobic. Only 2 ATP are produced.
I was talking without my microphone on. Great job. Who was that? Scrolling through my chat and I couldn't find you. Oh, great job, Alana. So perfect. So what do we do? Well, where does this happen? That's the very first place. Everybody put cytoplasm. Cytoplasm. Where are we in the cell? Where does this start? It all starts in the cytoplasm, or that jelly-like substance in our cell. All right. Glucose, that sugar that we've eaten, is broken down. All right. And we get 2 ATP. So everybody, I really want you to know before we leave today, glycolysis, GLY equals 2 ATP. When we go through the process of glycolysis, we're going to break down this little glucose molecule right now. And we're only going to get 2 ATP. Do you feel like that's a lot or a little? How do you feel about that amount of ATP? Tell me in the chat. I don't know if somebody says, hey, you could have $2. I mean, I'm thankful, but I'm not pumped about that. Right? So 2 ATP is nice, but it's really not that much. Right? What we really get excited about is this character right here. All right? It's called pyruvate. So I broke this down. If you do something today, please copy and paste these. I spent a long time last week making these images for you. I should have made them cheese. All right? But this is going to be a good picture reference of glycolysis. Where does it happen? Happens in the cytoplasm. It's the breakdown of glucose. All right? So I put a piece of candy right there. And what happens in glycolysis is that we break that glucose molecule. When we break a bond, what do we release? What is released when we break bonds? We talked about covalent bonds, ionic bonds. What happens when we break bonds? Ooh, you're right. We break up them from sharing electrons. When we break bonds, I want you to type this in chat. Bonds break equals energy released. All right? There is energy that is stored in bonds. Bonds represent potential energy. Everybody type that in. Bonds break. When bonds break, energy releases. I want you to think almost like of a firework going off. All right? When bonds break, energy is released. Okay? And when that energy is released, you're able to make an ATP molecule. All right? So in glycolysis, we make those 2 ATPs, but the biggest deal are these things right here called pyruvate or pyruvic acid. All right, we need these for the next step of cellular respiration. It's just like the dough for my noodles, okay? If I was making something and I just stopped with my dough ball, would I have a lot of noodles? Would I have a successful noodle making session? No. I would have like one giant pot pie noodle. I would have a loaf of bread. All right, so what is glycolysis? It's the breakdown of glucose. We're breaking bonds, releasing energy, and we really need not just those 2 ATP, but those 2 pyruvate molecules that we're going to use further down the line. All right, now we're going to see how much attention you paid. All right, so let's try to fill in some of these blanks. Glycolysis. What is it? Does anybody want to lead us through this? Glycolysis is a breakdown of what? Almost. You're getting energy. Yes, it is a type of sugar. What do we call that? Perfect. Thank you, Kaden. You got us thinking. Good. So does someone want to put glucose right here? Someone type glucose on the board. Glycolysis is the breakdown of glucose. Perfect. Where does it happen? Who remembers where in the cell it happens? Oh, yes. Good job, Madison. Good job, Thomas. Someone write cytoplasm. It happens in the cytoplasm. Where or what happens? So we have, let's put glucose right here too, because this is our glucose molecule. Our candy represents glucose. And when in glucose, when those bonds break, energy is released. Good. So what goes right here, Madison? You typed it. We're able to take that energy to make 2 ATP molecules. Somebody write ATP right there. Good. When those bonds break, we're able to capture that energy to make new bonds. So when our cell converts energy, what basically happens is floating around here in the cytoplasm are ADP molecules, adenosine diphosphate, and then extra phosphate molecules. All right. Then what happens is when that energy is released, that extra phosphate that was floating around, they gather the energy from that bond breaking, and you do ADP plus that extra phosphate to make adenosine triphosphate. So it captures that energy when you break glucose, and it attaches that phosphate to adenosine diphosphate to make ATP. All right. And so at the end of glycolysis, cool, we've got 2 ATP. And then we have these 2 halves of this candy that's left. What do we call that? Yes, good. Pyruvic acid. We have 2 pyruvic acid molecules, which actually ends up being our money. That actually ends up being the most valuable part of glycolysis, is that pyruvic acid. Can someone type that up there for me? Pyruvic acid. Perfect. All right. So that is glycolysis. You've got it. It's the breaking down or the breaking of bonds in glucose. When you break bonds, energy is what? Yes. Like my facial expressions. It's like, what is that game? Not Pictionary, where you act out the words. Charades. Yes, Vanessa. I'll just keep being like goofier and goofier until you guess. All right, energy is released. We make 2 ATP, and we end up with these very important pieces of candy left over, pyruvic acid. And tomorrow we're going to take these 2 pieces of glucose, pyruvic acid, and we're going to see why they are, like, what the hype is all about. Why do we need those pieces of pyruvic acid in the process of cellular respiration? All right. Ultimately, I'm going to give you a little. I'm goofy. I'm glad I'm goofy. I try to keep you entertained. All right. So we're going to take those tomorrow and see why they're actually the money in this process. I'm going to give you a hint. You're going to make a lot more ATP with those pieces of pyruvic acid than just the 2 ATP you made from glycolysis. All right. So that's why we want that pyruvic acid. Awesome. Fermentation. What do you think about when you think of fermentation? We're not going to go into all of this today, so don't look at those words and be like, in fact, I'll cover them all up for you. Cabbage. A lot of people think of bread. It's the process they go through for like making like beers and ales. Yep, you can do that, Peyton. All right, so fermentation is actually a way that our bodies kind of go to in like dire situations to make ATP. Yeah, so Xavier, when they ferment wine. This is a process. It's a less preferred process because it's not an efficient way of making ATP. But instead of using energy that you're putting in your body as glucose, it will use lactic acid in your muscles. Has anyone ever gotten a Charlie horse before, like in your, I always get them in my calves. Like where your muscle just like cramps up. And sometimes if I look at my leg, it actually would look like a ball on the backside of my calf muscle. Yeah, they hurt super bad. It's oftentimes because of a lack of hydration, all right, and potassium and oxygen, which is what your body needs to make ATP. They start doing it without oxygen, all right? That's what we call anaerobic. And we will talk a little bit more about that tomorrow. All right, so let's skip that. I had to ask you the chemical equation for cellular respiration, or at least what do you need to make it? What do you need to make it? Could you tell me? Let's do the poll because I'm close on time. Could you tell me what do you need? You need oxygen and you need sugar. Good. Much more confident this time. What about what are the reactants and products? So what are those things that you need and what are the things you get out of cellular respiration? Could you tell me that today? Leaving class. You need glucose and oxygen coming out. What do you get in the end? You get a little bit of ATP, you get water, and you get what do plants need? Perfect. Good job in chat. CO2. Good. And Where does cellular respiration take place? You know this. I guess this is asking about anaerobic. But let's just talk about cellular respiration in general. Where in the cell? Almost. It rhymes with ribo. Cyto. The mito is tomorrow, JV. You're right. Tomorrow we're going to move from the cytoplasm to the mitochondria. Great job. All right, lastly, this is what I want you to do as you leave. I want you to pick one of these, just put a dot like this. What are you going to do? Based on how you feel, based on what you just told me on that last slide, with where you were at with our goals, I want to know what your next step is. What are you going to do today to improve on that? Are you going to play a review game? Are you going to make yourself some flashcards? Maybe you're going to take that flow chart that I did up there and save it or make your own. Maybe you're going to go to YouTube and watch the Amoeba Sisters. Yes, you should do the Haunted House of the Cell, baby. All right, what are you going to do today? Put your pointer or put a dot on the screen as you leave. Because I want you to know what the next step is. Based on what you are telling me you gained from today, what's going to take you to the next level? Okay? I can only do so much in the 45 minutes we have together, but when you go the next step, that's going to help cement some of this in your mind today. Super proud of you. Mondays are hard. Awesome. I'm going to go back to that flow chart too right now. All right, so that if you want to go back and copy that, save it, you can. All right. Have a wonderful Monday. Thanks for being here. I know you have other classes to go to. I'll be around if you have questions. If not, I will see you tomorrow morning. Goodbye, Miss Brianna. Thank you all for participating, showing up, working hard. Bye, Josh. You can stay with me all day, Kensley. No, I wish. See ya, Paige.